Welcome students. I just come up with a question from the sliding friction. The question is determine the magnitude of P so that the system just starts to move down. Assume that the pulley is smooth and mu is equal to 0.25 for horizontal and inclined plane. So this is the exact arrangement. Here the horizontal surface and which is inclined with 30 degree, at that surface 3 kilonewton force is, and here it is attached with a coil or string or anything like rope. With the help of pulley it is transferring with the help of pulley and which is reaching the horizontal surface, and there we have the 10 kilonewton weight block, okay, which is a B. And it has been said we need to find the P force. The system just starts to move down. The force required to move the block A and B to downwards, that particular amount, that particular magnitude, we need to find it off. So here given data, weight at A which is given as 3 kilonewton, and weight at B which is given as 10 kilonewton, and here it is inclined with 60 degree, no issues. And here it is given the pulley is smooth. So pulley is smooth in the sense it's not rough, so there won't be any kind of friction force. And but here the horizontal and the inclined and the horizontal surface, it is been given mu is equal to coefficient of friction 0.26. okay, so both the surface it is with the same coefficient of friction 0.26. so in common I just taken mu. We know to find P force. So get into the solution part. Start with the free body diagram. So here in the free body diagram we can just take separately the block A and B. So if you consider the block A, the block A is something like this. We got it. It is something like this, 60 degree, and here is the block, and if I take the axis with respect to it, just put a cross line. So this is how the axis is. So if you take the axis something like this, here the weight, we know self weight of the any body will act right downward. So 3 kilonewton weight is just acting downwards, and see here the P force we need to find it off, which is something like this, going downwards. Okay, so I have noted, you can take it from the O. Okay, and then any other force, tension force is here. Since the rope is tied, okay, it is conveying with a pulley to the another body, let it be. Always see tension force will act just opposite or just away from the point. It's at one. When you take with respect to the point of that block, it always just convey opposite. Okay, that means it moves away from it. If I take here, it will be T, tension force T. Then the normal reaction will be acting at the contact. So it is here, and it will be just 90 degree to the surface. What about the friction force? So friction force is a resistant force. It's an opposing force which always act opposite to the motion. So here the motion concern, it is just given, it is moving downward. The block is moving downward, so that the motion is downward. It is just opposite, so it is moving something like this, the friction force upward. Okay, always predict the friction force with respect to the motion. Here the motion is downward, so here I have considered it is just moving upward, something like this. So all the forces have been taken. So then move to the next block. Okay, this is the block A, and here block B, I just going to take it off. So here it is a horizontal surface, so no issue at all. So take the axis, it will be very easy. So it is the axis, and the tension force, it is just here it will be acting. We know always the tension force acting on the, here the pulley is smooth, so no need to consider anything here. So the acting tension force will be equal to one another. So here it will act from the point which will be away from it. I have taken it, and the magnitude which is happening on the block A and block B will be equal. So I just taking n without any differentiation. It is a T. Okay, it is just a T. Both are equal in magnitude. That's the thing. Okay, and then self weight will be acting, that is 10 kilonewton. Then any other force, yes, normal reaction will be there, right? Normal reaction, it will be just moving inward, so I have taken here, okay, normal reaction. And then the friction force will be there, that is an important part when you are coming here. The friction force, see, the block A and B is tied by the help of rope, so that if the A just move downwards, where it moves, yes, just it moves to the where, left side. So motion is left, so that the friction will be towards right side. Have you got it? I hope you understood. Always take the friction force just opposite to the motion. Okay, so all the forces we have been taken here. Then just try to analyze the forces to identify the force P. Always when you are considering or solving the blocks, you must aware, always you have to start with the block which has the minimum number of unknown forces. So here P is unknown, friction F is unknown, N is unknown, T is unknown. 1, 2, 3, 4 forces unknown. Here comes 1, 2, 3, 3 forces are known. Where is the minimum number of unknown forces? Block B is the minimum number of forces. So we shall move with the block B, so that the calculation part will be more easier. Okay, so start with the block having the minimum number of forces. So I am considering block B. Consider the block B. When you consider it, I can say here the force, all the forces are T, tension force, friction force, normal reaction 10 kilonewton. So here apply equilibrium condition. When you are applying it, sum of horizontal force is equal to 0 and sum of vertical force is equal to 0. So start with the sum of horizontal force is equal to 0. The horizontal force is tension force and friction force. We are well familiar with the sign. When the force is moving towards left is a minus, and when the force is directing towards right is the positive sign. So here the tension force which is moving towards left, so it is a minus, and the friction force F which is moving towards right, so it is a positive sign, okay, which is equal to 0. What do you mean by friction F? We know the formula, coefficient of friction mu is equal to F by normal reaction. So F is equal to mu into N. Okay, so here we need to differentiate the normal reaction. It's an important part. When we are considering the normal reaction at the block B, it will be NB, and when the considering the block A, it should be N suffix A. Okay, so here we are dealing with the block B, so friction force which is equal to mu into NB. So here if I substitute over this equation, minus T plus mu value, we have it 0.26 into NB, which is equal to 0. Okay, so I just going to take this as equation number 1 because I don't have uh, or next simplification step, so I just leaving with this. Then sum of vertical force I just going to apply, which is equal to 0. So I add all the vertical forces here. Two vertical forces, one is 10 kilonewton and NB. So here force moving towards up is a positive and downwards is a negative. So here comes NB, which is upward, so positive, and the force 10 kilonewton is a downward, so minus, which is equal to 0. So NB is equal to 10 kilonewton. Reaction, normal reaction at B, we got the answer, which is 10 kilonewton. Now, if you put this value, substitute NB and the equation number 1, so that the equation number 1 will be minus T plus 0.26 into 10, which is equal to 0. So that here you will get T, which is equal to when you take this T to the other side, it will become positive, and if you simplify this, it will be 2.6 kilonewton. This would be your answer. Okay, this would be your answer. Now we got two answers. So by the help of the block B, these are the two answers we can find it out. What is the thing? We need to find the P, which when you are considering the A, we will get the answer for it. Okay, so now consider block A. Consider the block A. Apply here the sum of horizontal force is equal to 0 and sum of vertical force is equal to 0 at equilibrium condition. Sum of horizontal force is equal to 0. I just applying it. So here, before apply it, one more step we shall add it off, so that the explanation will be simple and you can also understand the exact thing what the force is saying to us. So what I done is I have been just tilted the angle to the 0 degree. That means I tilted the axis to the 0 degree. Okay, tilted. So here the T force is acting something like this, and the P force is acting something like this from the point, something like this, and here the friction force is acting something like this. Okay, and the friction normal reaction, which is acting upward. Okay, normal reaction, and the 3 kilonewton force is somewhere here. So since it is inclined, definitely it will be 2 force. Since it is in a third quadrant, I can say it is moving something like this, so I can say it can be moving horizontally left and vertically down. So this is how. So when you are just taking the magnitude of the force, we need the angle. So here this angle we need to calculate it. It's so easy. Just take this as a triangle. Take this as triangle. It is with the 90 degree. So what is the other side? So total angle is 180 degree. So 180 minus 60 minus 90, we get 30 degree. So this is with 30 degree. We know opposite angles are equal, so this also will be 30 degree. So here the magnitude will be 3 cos 30 degree. Here 3 sine, it's a vertical one, so sine 30 degree. That's all. Now if you calculate it, it will be sum of horizontal force is equal to 0. Here the horizontal force is friction, and then T, then P, and this 3 cos 30 degree. This is friction at A, this is friction at B. So we can differentiate it. This is at B. Okay, so here as well it will be with the B. Okay, so we can differentiate as block B, so we can take all the things at block B. Okay, so here the force moving to the left is a minus and right side is a positive. So these two forces are positive one, T plus FA, and these two forces are negative one, minus P minus 3 cos 30 degree. We know both the what the tension force, tension at A and tension at B, which is equal in magnitude. So when you put it off here it will be T is equal to 0.6 plus FA. So here we shall calculate it, mu is equal to FA divided by NA. Okay, here is NP. So here what happens, FA, which is equal to mu into NA. So here comes 0.26, mu is 0.26 into NA minus P value we need to identify, which is equal to 3 cos 30 degree. And the next step, when you simplify it, I can say it will be 0.26 NA minus P, which is equal to 3 cos 30 degree minus 2.6. So that here you will get 0.26 NA minus P, which is equal to minus 1.9237 into 10 to the power minus 3. Okay, you will get the answers something like this when you are simplifying it. So I just going to take this as equation number 2. Then put sum of vertical force, which is equal to 0. So here the vertical force is concerned, only we have two vertical forces. So here we have only the two vertical forces, one is NA and 3 sine 30 degree. NA is which is just directed upward, so it is a positive. Then 3 sine 30 degree, which is directed downwards, so that it is a negative sign, so it carries minus, which is equal to 0. So directly we will get the answer for NA. Take it to the next side, I can say you will get the answer as 1.5 kilonewton when you are simplifying it, plus. Okay, now just we shall substitute in equation number 2, so that this equation number 2 will be 0.26 1.5 minus P, which is equal to minus 1.9237 into 10 to the power minus 3 it will be. When you are simplifying it, you will get the answer for P. I can say P is equal to 0.392 kilonewton. When you are simplifying it, take this P to the other side, so it will be positive, and bring it to the other side, so it will be positive. So if you put 0.26 into 1.5 plus 1.9237 into 10 to the power minus 3, you will get the answer as 0.392 kilonewton. Okay, so I hope you understood. When you are having the two blocks, something like this, A and B, and which is tied with the help of ropes, just keep it in your mind. Whenever you are having two blocks, just separate it and just identify what are the forces in the blocks. Okay, and just start analyzing the forces in it by having the logic that the block which having the minimum number of force should be picked first in order to solve it. Okay, so here the block B has the minimum number of force, so I have taken it and just proceeded. So here when you are coming to the normal reaction and the friction force, always remember you need to specify the specific name. If it is block B, you need to give N suffix B. friction n suffix b. So here in the block A I have specified n suffix a and f suffix a. So you can avoid the confusions. So such manner I have proceeded some of horizontal force and vertical force. I just got the values. So here comes when you are having the ropes, just keep it in your mind, tension force will be just equal. So equal in magnitude, and direction will be changed, but the magnitude will be similar. So with the help of that logic I have just substituted, and just I have found the P value which required to pull the blocks downward. So P 0.392 kilonewton is the required force to move downwards. Okay, so hope you understood. Thank you so much.